Everybody is clear on this problem? Anybody
Yes, sir.
this? Okay, see, okay, how to solve this? So whenever this type of problem comes, I told you the tension acceleration is different. That acceleration here is different. Acceleration here is different. Tension here is different. So now the string is constant. This string is one string. Okay. So this tension is constant. Whenever the string is same, the tension is same. This tension is different. Why? Because these are different string. So T here, T here. This will be how much? 2T. Clear? Clear?
Yes, sir.
Yes, sir.
Next. Acceleration here is different. Acceleration here is different. How to find? So basically for this we have to find formula AP. Pulley. So this will not change. This is a movable pulley. If you pull it down, this pulley will go up. This pulley will basically go up. This pulley will go up basically. That means the pulley is moving. Pulley is having acceleration. So what is the formula? I told you A1 plus A2 by 2. This is the formula. And I told you whenever there is a downward movement, you take negative. Whenever there is an upward movement, you take positive. Clear? Now 2 kg.
Yes.
If 2 kg is heavier, obviously this will go down. This will move up. Correct? Yes or no?
Yes,
This
sir.
will go down. This will move up. So now when this moves up, so what is the pulley? Pulley is positive. So AP is positive. Now what is A1? This acceleration and this acceleration. This A1 is what? 0. Why? Because this is fixed. This string is fixed. So this acceleration is 0. But what about this acceleration? We do not know. We do not know. Okay? So now this acceleration is A. Let us. This also A and this also A. The acceleration is same here and here. Here. Okay? When you pull down, this will also equally move up. So acceleration here and acceleration here. Same amount is this, only direction is different. Here it is downwards, here it is upward. So how it will be? This will upward. A1 is 0. So 0 plus A2 is what? A2 is upward. So positive. So A divided by 2. That means your acceleration of pulley is A by 2. That means if this is A, this will be 2A. Correct? Understood? If this pulley moves up
Yes, sir.
in A, this will move in 2A because the acceleration of the pulley is half of the acceleration of this one. Clear? You can consider anything. You can consider A by 2 or A, your wish. Whatever the acceleration here, this will be double here, or whatever is here it will be half of that. Clear? Clear?
Yes, sir.
This is one way of understanding. There is another way of understanding which I will explain you. You understood this problem? All of you understood this way? Siddhi? Did all of you
Yes,
understand?
sir. Understood, sir.
Yes,
Okay.
sir.
This is the simplest way, but there is another way. How? I will explain. Wait. Okay, now see. When you are pulling, this, let's say this mass is coming here. Let us say I am extending it 1x distance I am pulling. So what will happen? This string will get pulled. But what about this one? This string will also get x, it will get pulled. And this will move up. How much? The pulley will move up. How much string will get used? Here x, 2x. Understood? 2x. If you pull this x down, the total string will get pulled is how much? 2x. Why? Well, x from here. Correct? Yes or no? Yes or
Yes,
no?
Yes, sir.
Similarly, if you move this down by x, so this will move by how much? How much? 2x. Because if you pull it x down, so x from here, total is 2x. So 2x will get it. So if you pull it down by x, this will move out by 2x. So this is one way of understanding. But always take this formula. This formula is valid for all the movable pulley. So now we got it. This will move up by 2a acceleration This will move down by a acceleration. Now put down the formula. Put down this formula. It will be what? This is moving down. So 2g minus t is equal to 2a. Correct? 2a? No. 2 into 2a. Why? Because sorry, I made a mistake. This is moving up with acceleration a. This is moving downwards with acceleration 2a. So the acceleration is 2a. So 2 mass is 2 into acceleration. Here for this one, what is the equation? This is moving upward. So upward means t plus t is 2t. So 2t minus this is 1. So g is equal to how much? This is moving upward. How much? So a. Correct? Clear?
Yes, sir.
So how much? This will be 2g minus t is equal to 4a. This will be 2g minus g, sorry, 2t minus g is equal to a. In this type of equation, see here it is 2g, here it is t. So can we, normal addition will not lead to the elimination of t. So what you should do? So in this method, you have to multiply. What you have to multiply? You have to solve the equation. So what is the equation again? Let me write 2g minus t is equal to 4a. Here it is 2t minus g is equal to a. So what I am doing, I am multiplying here 2 here. If I multiply 2 here, what this equation becomes? This equation becomes 4g minus 2t is equal to 8a. And this equation I'm writing here 2t minus g is equal to a. Now you can add this equation. If you add this equation, 4g minus g is how much? 3g minus 2t plus 2t, 0. 8a plus a is 9a. So now what is a? 3g by 9 equal to g, 3g by 9, g by 3. Clear? Clear?
Yes, sir.
All of you clear? Siddhi, Pritam, Laksh, all of you clear?
Sir.
Yes, sir.
Pritam clear?
Yes, sir.
Now you got g by 3, right? Put in this equation. You can find what is the t. Clear? Clear? Yes? Okay. Swarup, clear?
Yes, sir. Clear, sir. Yes.
Okay, so let us go to the next topic. What is the next topic for today? Who will tell me? Who will tell me what is the next topic? Who will tell me? Yes?
Sir, I have a doubt, sir, in the last class that
Yeah,
the
yeah.
inertial and non-inertial frame.
Yeah, tell me.
Sir, can you explain that lift sum again, sir?
Okay, next talk. That sum I need to explain again? No problem, I'll explain.
Yes.
Okay, no problem. I actually expected. So good that you told. So what is there? I told you there is a lift. Okay, in the lift there is spring balance. And there is a pulley. This is 3 kg. This is 1.5 kg. Okay. Now this is moving upward at an acceleration g by 10. G by 10. That means how much? 1 meter per second square? Almost. Correct or not? Yes?
Yes, sir. Yes, sir.
You have to find what is now pulley, the lift is moving, but due to the weight of this masses, there will be an extension in the spring or not? If there would not have any lift, pulley or
Yes, sir.
the spring would have been like this. But since there is a weight, the spring will get extended. But there is an extension of the spring. There is also a movement of lift. So it is very complicated. Okay, it's very complicated if you want to solve it from an inertial frame of view. Okay, from a inertial frame of view. So what you should do? You should be in a non-inertial frame and try to solve it. What do you mean non-inertial frame? You cannot be observer at rest, because for you there are multiple variables. This is moving downward. This is the lift is that the pulley is moving. This is moving. This is moving. It becomes very difficult. So be inside and solve it. And for this type of problem, whenever you are using a non-inertial frame, there will be a new force. What is that force called? What is that force called? Yes. What force? All of you. Once tell me in one go. What is that force called?
Pseudo force.
All of you tell. All of you. Pseudo force.
Pseudo force.
All of you. Very good. Tell one shot. Pseudo force. Okay. Pseudo force is an imaginary force. Okay. Imaginary force. It is basically a correction. It is a correction to what? Which law? Which law? Which law? Newton's second law. Newton's second law. F equal to ma. This is the Newton's second law. It is a correction to this law because this law only speaks about inertial frame. Okay, inertial frame. But whenever the non-inertial comes, this law will fail. So pseudo force is an addition or the corrective force to make the Newton's second law what? Valid. Clear, all of you? Clear or not?
Yes, sir.
सिद्धि क्या हो गया? खाना नहीं खाए? Okay. So now what happens? तो बोला करो. I'm asking. So now
Yes, sir.
what we will do? Obviously, when this person is moving, so this person is actually seeing what? Only this setup to be down. He is not seeing the lift going up. For him, it is nothing. It is immaterial because he is also moving in the same direction. He is also moving upward. So both are at rest with respect to each other. All of you clear till now? Any doubt here? Any
No,
doubt?
sir.
No, sir.
Tom, clear?
Yes, sir.
Okay. Then what we should do then? Whenever this type of problem is there, obviously, what will happen? I told you that. Tell me what are the points of pseudo force. What did I tell in pseudo force? Tell me one point. One point.
Sir,
Pseudo
it will
force.
be,
Yeah.
1 second, sir.
Tell me. Read out. Everybody, look at the notes. What did I tell in pseudo force? The force to be applied on the object opposite to the direction of acceleration.
Yes, sir. Yes.
The force will be applied on which one? Which body? Pseudo force applied on which mass? Which mass? Which mass? 3 kg. 3 kg or 1.5 kg? Which one? Who will tell me? Who will tell
3
me?
kg.
3 kg or 1.5 kg? 3
Sir, I
kg.
think it's 3 kg.
3 kg?
3 kg, sir. 3 kg.
Yes, perfect. So it will be applicable on 3 kg. Okay? Clear?
Yes, sir.
So now what will let us draw
Yes, sir.
the free body diagram. This tension is upward. Now I told you we are removing the spring with a string. So this T, this is T, this will become 2T. So this will become 2T. The spring, that means the spring force will become how much? Spring force 2T. Clear? Clear or not?
Yes, sir. Yes, sir. Clear.
Yes, sir.
The tension is moving upward. This is moving upward. This is moving downward. So with this is tension, what is the weight downward? 1.5 G. Correct? Yes or no? Yes or no?
Yes, sir.
Next what? What about this one? 3 kg. This is 1.5 kg.
Yes, sir.
This is moving downward. When this is moving downward, the tension is there. The tension also acts here. This is moving downward. So it will be 3G. Clear? Clear? Yes?
Sir, I have a doubt, sir.
Yeah.
Sir, that 1.5 G will act upward only, sir, because like the 3 kg is heavier, so the 1.5 kg will tend to move upward, sir.
Upward only. No, I'm putting this upward. No?
So, okay, sir.
And this is moving by
Yes,
A.
sir, yes.
Correct? This is moving by downward A. Yes? So let us write the equation. For this one, what it will be? T minus 1.5g. Yes? Yes or no?
Yes, sir. Equal to
Equal to?
1.58.
Is it so? Wait 1 minute. Hey, why will the pseudo force act only on 3 kg? It will act on both, no? It will act on both, no? Why will only act on 3 kg? It will act on both, right? Yes or no? Will it not act on both? What is the acceleration of observer? What is the acceleration of observer? Upward, yes? Upward.
Yes, sir.
What about this one? This one also moving upward. So ideally it should act on only on 3 kg, correct? So T minus 1.5 g is equal to how much? Is equal to how much? 1.5a, correct? And for this one, there will be another pseudo force. So it will be 3 into how much? Which acceleration? This one. 3g by 10. Okay? Yes or no?
Yes, sir. Sir, I have a doubt, sir, that A is the acceleration of the lift, sir.
A is the acceleration of which A? This one.
Yes, sir.
No, here, this one.
The pulley only, no, sir.
Yes, pulley. The string moving up and down.
Yes, sir.
Okay, and here it will be what? This will move down. So what it will be? So it will be 3g. This also moving downward, correct? Plus 3g by 10 minus t is equal to how much? This is moving downward. So 3a, correct? Correct or not?
Sir, why did the 3g by 10 come, sir? Like,
Because what is pseudo force? Pseudo force is what? What is the definition of pseudo force? What acceleration it will take? Acceleration of observer. And observer is moving upward in what acceleration? G by 10, no?
yes, sir.
Yes or no? Acceleration, what is the observer is moving upward, no? What acceleration? G by 10.
Yes, sir.
So pseudo force is what? Mass of the object into acceleration of the observer. Acceleration of observer is how much? G by 10. So 3g downward, weight downward, pseudo force downward, tension upward. But the net direction is downward. So this force is more. This force plus this force minus this force is equal to the net acceleration, that is 3a. Net force is 3a. Clear?
Sir, why isn't that pseudo force acting on that 1.5 kg block, sir?
It is not acting. No, when did I tell it is acting?
Yes, sir. I'm asking the reason.
Why it is not acting?
Yes, sir.
Because what is the definition of pseudo force? Pseudo force will be applied on the object opposite to the direction of acceleration. Opposite to the direction of acceleration. Of what?
Oh, okay, sir.
Of what?
Yes, sir. I understood.
Observer. Okay?
Yes, sir.
Opposite direction of observer. Because this is moving upward, observer is moving upward, pseudo force is not acted. Only when this is moving downward, observer is moving upward, here the pseudo force will act. Clear? All of you clear? Siddhi,
Oh, okay, sir. It's
Swaroop.
clear, sir, clear.
Yes, sir.
Then
Yes, sir.
Then the simple, no, you
हाँ
can,
sir.
then you can find out. That's all. Clear? All of you. So subtract, G by 10 is what? 10 by 10 is 1. So this become 3. So 30 plus 3 is 33. Whatever you can find out now. Okay, let us go to the next problem. All of you clear, no? Okay, good. So now we will go to the topic. What is the topic for today? Friction.
So now from here we can find A, no sir, like after
You can
equation.
find A, you can find T. Once you find T, you can find out the FSP. Spring force is how much? 2T, correct? Spring force is how much? 2T. Yes or no?
Yes sir, yes sir.
And if you have delta X, if you have spring constant, you can find out the extension because FSP is equal to K into minus K into delta X. K is not given. If you get K, you can find out the extension in the spring. Yes or no?
Yes sir.
Once you find A, you can find T. If you find T, you know 2T. You know 2T, you know FSP. You know K, you can find out the delta X. How much? Because FSP, delta X will be how much? Extension in the spring will be how much? FSP by delta K, correct?
Yes sir.
What is FSP? 2T. 2T by K is how much? Delta X. So how much the spring will get extended because of this one is delta X. Yes or no? Clear?
Yes sir. Yes. Sir, and then in the beginning of today's class you read one sum, no, sir.
Yeah. Tell me. Yeah. Doubt in
Sir,
that?
one small doubt, sir. In that, like that 2 kg block is moving downwards because of the greater mass only, no, sir.
Correct. This will move. This is 2 kg. This is 1 kg. Obviously, this will move down, no?
Yes sir. Yes sir.
So when this will
So
move, down, it will move up. This pulley will move up here.
okay sir. Okay sir.
So here A will be G by 3. You cannot apply here the formula F net by what? M net. This is only applicable for which pulley? Fixed pulley. Okay? Apply for fixed pulley, this formula. You cannot apply the shortcut formula here. This is a movable pulley. When movable pulley is there, you have to find by equation only. Understood? Understood all of you?
Yes sir. Yes.
Okay. So let us go to the friction. Okay, what is friction? Who will tell me? Basic definition, Swarup. What is friction? What is friction? Swarup. Swarup, what happened? Anybody tell what is friction? Laksh? Pritam, what is friction?
Friction is a force which, like, it opposes the motion, sir.
Motion or relative motion?
Relative motion, sir.
Yes. So friction is a force, is opposing force. Okay. Okay, opposing force acting on the relative motion. Means if you have a body, if you want to pull it this way, so friction will always act this way. This is the friction, this is the force you are acting. And this is the friction force, FP. Friction is written like this. This force, so the net force will be F minus F is equal to, if the friction is more than this, object will not move. That means you have to pull it so hard that it will overcome the friction. So if you are pulling at 10 Newton and friction is 2 Newton, so the net force acting on the object, that is 8 Newton. Understood? Clear? Yes or no?
Yes, sir.
क्या बोल नहीं रहे हो स्वरूप? चुप हो
हाँ
जाते
सर.
दोनों, सब लोग चुप क्यों हो जाते हो? मैं जब पूछता कोई बोलो तो one of all of you should, some of you should tell, no? Everybody, all of you are in the class, right? I am not teaching only Pritam or I am teaching only Laksh, right? I am teaching all of you. Am I correct? So why are you not answering in the class when I'm asking? As a teacher, will I have to shout every time? पूछना पड़ेगा मेरे को. I have to individually call out names. Is it so? Is it so, guys? I have to do it every time.
No, sir.
Then I'm asking you, Swaroop, tell me. None of you are answering. Laksh, क्या हुआ? He's still now not answering. I don't know what is that. So there are two types of friction. Seriously, I don't know, yaar. This actually pulls me down here. Come on, discourages me. I'm asking you somebody. You should answer. Make it interactive. Otherwise, YouTube is there. No, YouTube. There are many good professors who teach. You learn from there, no? Because teacher-student relationship has to be live. You cannot do recording. I know recording is important, but I'm saying that then the teacher is not required, no? Be interactive in the class. Participate in the class. I'm asking something. If you have a doubt, how will you ask a teacher if you're seeing a YouTube? Teacher is important. Like that, student has to participate. I'm not a recorded version that I'm just telling and you will see. If you don't participate, I will not have the interest to teach you. Yes or no?
Yes, sir.
Then
Yes, sir.
why am I every time I have to call out individually? So there are two types of friction. One is static friction and one is kinetic friction. So is it clear from the word what is static? Pritam, what is static and what is kinetic?
So static friction, like it comes to place when the body is at rest.
So if you have an object at rest, if you want to pull it, this will not get moved. So when the body is at rest, the force which is acting, it is called static friction. And when the body is moving, let's say there is a cart which is moving. Okay. When you're pulling, the friction which acts on it, both the wheels, is called kinetic friction. That's it. Nothing more. When the body is at rest,
So static friction will remain zero, right?
no. Why? Why?
So because no force is acting on the object.
I did not say that. I said what? I said you are pulling the object. You are just starting to pull the object. The body did not move. The frictional force what acting on the body when you are pulling is called friction.
So means
friction.
Yes,
See,
sir.
the body is at rest. I am coming and pulling it. The labor is coming and pulling it. When you start pulling, it is not moving at all. You are just applying the force. The force which is acting is called static friction. When the body is at rest. And the friction which act during the motion of the body is called kinetic friction. Clear? Clear?
Yes, sir.
Friction will only act when there is a tendency of relative motion. Tendency. When you're about to start. When there is no motion, why the friction is very clever. It will not act when the body is at rest. It will only act only when you are about to pull. When you are about to pull, that time the static friction will come into picture. Because you are pulling from the body at rest towards motion. So that means the static friction is only acts only when there is tendency of relative motion. When you are about to pull an object, you are not pulling an object, then friction is not acting. It is just remaining there. Because the motion is not, the tendency is not there. You have not started to pull the object. Clear? Clear or not?
Yes, sir. So means the
sir.
frictional force is more than the force applied by any person or external force.
Friction force
Then
is
it's static friction, right?
what is sorry, what is the doubt?
So means when the frictional force is more than the external force, then it will be static friction, right?
No, don't get confused. What I said, first this body is there. You are coming and pulling it. You are just pulling it. Moment you pull, you have not started to pull. You are just pull. When you are pulling, the force is acting opposite direction. During the rest, when you are about to pull the object has not started moving. Your tendency, there is a moment you start pulling, about to pull. The force acting out opposite is called static friction. Once the object starts moving, you are riding it, the ice cream wala is riding. That time this is in rolling motion, rolling. This is called rolling friction. So rolling friction is one of the kinetic friction. Okay. During the motion of the object is called kinetic motion. During the body at rest, but there is a tendency. You have to pull it. You have to pull it. Tendency relative motion is there, static friction. If your frictional force is greater than the applied force, will the body move? No. The body will not move. Okay? The body will not move. So
Yes,
you
sir.
have to apply the force in such a way that it overcomes the friction. It overcomes the static friction. Only when you pull hard, then only it will get moved. Clear or not? Ritam,
Clear,
clear?
sir.
Yes, sir.
So let us talk about kinetic friction, because static friction, I don't think much is there. So what is kinetic friction? What is the formula of kinetic friction? Kinetic friction is given by Fk. F
Yes, sir.
equal to, क्या हुआ लक्ष्य, अभी तक क्यों नहीं बात कर रहे थे? आई एम कॉलिंग आउट योर नेम.
सर एक्चुअली मैं लैपटॉप की बैटरी खत्म हो गई थी सर.
But you are there in the class. Okay. So
इसलिए
F,
मैं सर निकल गया था.
Fk is what? Fk is mu k into n. Mu k into n. What is mu k? Who will tell what is mu k? Mu k is
The coefficient of kinetic friction.
perfect. Coefficient of kinetic friction. It's a constant. It's a constant. But what? It's a constant for what? It will depend on the surface. Mu r for ground is different. Mu r for sand is different. Mu r for ice is different. Mu r for muddy road is different. So it will depend on what? On the surface. What type of surface it is. Note down, note down. It will depend on type of surface. For a particular surface, it is constant. Clear? Clear or not?
Yes, sir.
Yes, sir.
And what is n? Who will tell n? Who will tell n? N is normal. Normal reaction force. Normal reaction force. Clear? Normal reaction force. Okay. So let us do a small problem. There is an object. Okay. Object is being pulled at 10 Newton. Okay. Obviously, this is a 4 kg. It is 4 kg. That means the weight it is downward is 4 into g. That is equal to 40 Newton. What is the normal? Normal will be same, 40 Newton. Yes? Yes or no?
Yes, sir.
Yes, sir.
हाँ सर.
Mu r is 0.2. Mu r is 0.2. Mu k is 0.2, not mu r. Mu k, it is k, not mu r. So what will happen? Fk is equal to mu k into n. So mu k is 0.2. N is how much? 40. So how much it will be? How much? 8 Newton. Applied force is 10 Newton. So applied force is 10 Newton. So net force is how much? Net force is being pulled is 8 minus 2. 8 minus 2. 2 Newton. Clear? Yes or no?
Yes, sir.
Clear? All of you clear?
Yes, sir.
हाँ सर.
Become clear? Okay. So let us go to the next problem. You have an object here. I am not pulling I am pulling at a what? At an angle. F is equal to 10 root 2 Newton. Okay. Same 4 kg. Same 4 kg. 45 degree. I am pulling like what? Like this. Means a man is standing and he is holding like this and pulling like this. Okay. You have to find what is N. You have to find what is Fk and you have to find A. So who will tell me how much is N? This is very easy. N is how much? How much? Yes or no? Am I correct? N is equal to 40 Newton. Yes? Mu k is given. How much?
Yes, sir.
0.3. Mu k is 0.3. So now what we should do? What you should do? What you should do? Whenever there is an angle comes into picture, we have to split into components. So this will be F cos 45. This will be F sin 45. Understood? F cos 45 and sin 45. So that means there will be two force upward, normal and something else. Normal and something else. Yes or no? So the normal will not be 40 Newton only. So what is upward force? F sin 45. F sin 45 is how much? 10 root 2 sin 45 is equal to 10 root 2 divided by 1 by root 2. That is equal to 10 Newton. So upward there is a 10 Newton force. Clear? Yes or no?
Yes, sir. Yes, sir. Yes, sir.
Yes, sir.
And downward there is a 40 Newton. That means N plus 10 is equal to how much? 40 Newton. Am I correct? Yes or no? N plus 10 Newton upward, this component F sin 45 is equal to 40 Newton. Then what is N? 40 minus 10, 30 Newton. So first answer is 30 Newton. This is wrong. 30 Newton. Then what is F cos 45? F cos 45 is again 10 root 2 into 1 by root 2, because sin 45 cos 45 is 1 by root 2. This will be again 10 Newton. Understood? This is again 10 Newton.
Yes, sir.
The force, the net force is 10 Newton. That is equal to MA. So 10 Newton is equal to M into A. What is A? But is it 10 Newton? No. Because we have to find Fk. This is not the actual force. So we have to find Fk. What is Fk? Fk is mu k into Fk is mu k
N.
into N. N is how much? 30 Newton. Mu k was 0.3. So what is Fk? Fk is 9 Newton.
9 Newton.
That
9
means
Newton.
there is an object here. It is being pulled at 10 Newton. This is 9 Newton and this is 4 kg. So actual it will be how much? Only 1 Newton. So that
1
means, so force is equal to ma. You have to find acceleration. So acceleration will be F by m. F is how much? 1 Newton. This is 4 kg, 1 by 4. That means 0.25 meter per second square. All of you clear?
Yes, sir.
Yes,
all
sir.
of you clear? All of you means all of you. Everybody has to say yes.
Yes,
Yes,
sir.
sir.
Yes, sir.
Very good. Very good. Now, who will do one more problem? Try to do one more problem. All of you, this for all of you. The two forces, one is this way, one is this way, and this is 10 kg. Find Fk, find A, and find N. Find out. Find out, find out. All of you, start solving.
Yes, sir.
Sir, what is mu K, sir?
Mu K is 0.3.
Sir, N is 90 Newton.
Are you sure?
Yes, sir.
Okay, let us see.
Yes, sir. N is 90 Newton.
All of you get a
And,
9.
and
Lux,
Yes, sir.
Yes, sir.
okay, what is FK?
sir, and sir, it is
Sir,
27, sir.
27. Yes, sir.
Okay, acceleration.
So 0.3.
Okay, let us see. So obviously you will have 2 upward. So it will be 10 downward. So 10 into 10, 100. 100 plus 10 is n plus 10, n plus 100. Sorry, n plus 10 is equal to 100. So n will be 90 Newton. Okay, correct. So 90 Newton, 90 into 0.3. It will be how much? FK will be how much you got?
27.
Okay, 27, very good. So 27 this side 20 plus 10, 30. So 30 minus 27 is 3. 3 divided by m is 10.3. Very good. All of you good. Very good, very good. Good. Okay. So let us do next. We'll study static friction. I will extend the class today more because yesterday class we missed it. So I actually wanted to finish this way, but Christmas, many people, it was announced holiday. So that's why. No problem. That's okay. We can cover up. Don't worry. Okay. Static friction. Remember, static friction is a variable function. Is a variable friction. Why variable? It will depend. It will depend. Initially, when you pull an object, it is difficult. But moment you start pulling, it is easy. Initially, when you start about to pull an object, it is difficult. So the static friction is actually it will range from 0 to F limiting. You'll say, what is F limiting? Limiting is friction is the maximum static friction. That means the static friction is it is basically like a range. It starts from 0 to F limiting. F limiting the maximum. F limiting is the maximum what? Static friction. Static friction. Maximum static friction. The maximum static friction is called F limiting. It's also F. So F limiting will always be equal to Fk. Remember this. Note it down. F limiting is always greater than the Fk. So this static friction is a variable friction. It will increase or decrease depending on the situation. What situation? You have a body at rest. When you come and start pulling, moment you start pulling, it is the maximum F limiting applied. When you start, after you start pulling, it reduces. Because you're not completely started moving. You're not completely started moving. The moment you start, it is the maximum force is that applied. That is equal to F limiting. Clear? Clear?
Yes,
So
sir.
this F limiting formula is what? Coefficients of static friction into N. This is the formula. Like Fk is equal to mu k into N. Similarly, static friction is mu s into N. Clear? Clear?
Yes,
Same,
sir.
you have a 4 kg. You are pulling at 6 Newton. So what will be the static friction? Limiting friction? How it will be? So N is 4 K. So this is 40 Newton. So N is 40 Newton. So mu s is how much? Mu s is 0.2. So 0.2 into 40 Newton is how much? How much? 8, no?
8 Newton.
Newton. Correct? But will there be an acceleration? Will there be an acceleration? No. Because static friction acts at body at rest. So A should be what? What should be A?
0.
A should be 0. A should be 0. Why? Because your Fk is 8 Newton. Fk is 8 Newton, but you are pulling at 6 Newton. So will you able to move the object? No. Because the applied force is lesser than the frictional force. So body will
Frictional
not
force.
move. Clear?
Yes,
Clear?
sir.
Yes, sir.
Okay. Do one more problem. This all of you do. Again, same 4 kg. You are pulling at 20 Newton. Mu s is 0.6. Mu s is 0.6. And what? And yeah. Find out the acceleration. Yeah, find out. Find out.
Sir, acceleration is 0, sir.
Yes, because why? Because your Fk will be 0.6 and this will be 40 downwards. So upward will be 40, N will be 40. 0.6 into 40 is how much? 24 Newton. This side 24, this side 20. So F limiting is greater than F applied. So A is 0. Clear?
Yes, sir.
Clear?
Sir, the static
sir.
friction is 20 Newton only, no, sir.
Why static friction is 20 Newton? No, this is Fs. Fs is mu k, mu s into N. N is 40. Mu s is how much? 0.6. So 0.6 into 40 will be 24 Newton, no? Why you got 40 Newton?
Yes. No, sir. Like I'm asking, like the limiting friction is only 24 Newton, sir. The static friction should be 20 Newton, sir. Otherwise, sir, it won't be like logical, sir. Because one side if it's 24 and the other side if it's 20, then like it will be unbalanced, sir.
No. 1 minute. So you are saying this side 24, this side 20. So it is illogical.
Yes, sir. So it should be 20 Newton, sir. Static friction should be 20 Newton.
No,
Limiting, like it acts only when the applied force is 24, sir.
that's okay. So this force is only acting upward. It is downward, it is acting. It is not making the object move. You might say, sir, 24 Newton this side, 20 Newton this side. So ideally the object should move this side, correct?
Yes, sir.
It is not so, no? You are not acting on.
Yes, sir. It is not.
It is
Yes,
cannot
sir.
be.
That's what I'm telling, sir. Yes, sir. So I'm telling like the static friction should be 20 Newton, sir, so that like both will cancel each other.
Correct. Your question, your answer is correct. Only what you're saying. What did I say? What is F limiting? What I said starting? It's a maximum force. It is the
So that's what when I told,
maximum
sir.
static friction. So ideally, if you are pulling 20 Newton, this friction is still 20 Newton only. It is the static friction. That means the static friction is between so this is the limiting friction. This is the static friction. That means 20 is getting cancelled. Object is not moving. That means you have to pull in such a way that you are overcoming the maximum limiting friction. Limiting friction is the maximum friction. Understood?
Yes, sir.
Maximum friction. You are correct. You are saying, sir, obviously It has to be 20 Newton only. Yeah, it has to be 20 Newton because 20 cancel out, object is not moving. But whenever we cannot find out the static friction, so always we talk about F limiting because it's a variable function. We don't have any function. So we always talk about the maximum friction, what is acting, not the exact 20 Newton. All of clear, Pritham?
Yes, sir.
Now,
Clear, sir. Clear.
we will only talk about
Yes,
the
sir, clear.
maximum friction, maximum static friction 24 Newton. Obviously, one function is more than that, how it will move. But maximum is itna. How much is applicable is 20 Newton because 20 this side, 20 this side, both gets cancelled out 0. You don't require 4 more Newton friction force. Correct? Correct or not? Yes or no?
Yes, sir.
Okay, good. So now what we'll do? Let us find one more problem. Let us do one more problem. 2 kg pulling at 20 Newton. Okay, your mu k is how much? Mu k is 0.4, mu s is 0.6. So find out what is friction and what is A.
Yes, sir.
Will the body move? First find out. F limiting, first find out what is F limiting. F limiting is how much? Newton, correct? So this side 12 Newton, this side 20
Yes, sir.
Newton. So that means body will move, correct? So how much the body will move? Body will move, correct or not? You know the body will move.
Yes, sir.
Now when the body will move, is there any other friction acting? Is there any other friction acting when the body moves? What friction will act when the body moves? What friction is acting on the body moves? Kinetic friction.
So kinetic friction.
That's what tell no. Baba mone class ro pare batao. So that means the kinetic friction. So what is kinetic friction? Mu k into n. What is mu k? 0.4. What is n? N is how much? 20. So how much? 8 Newton. So now what is acceleration? So what is the net force? Net force is 20 minus 8. That is equal to how much? 12 Newton. So what is the acceleration? 12 by 2. 6 meter per second square. Clear? Who didn't understand? Tell me, I'll explain again.
Yes, sir.
Did not understand?
Sir, please explain the last part.
Yeah. See, whenever static friction will tell us whether the body is moving or not. Body will move or not. So this is 2 kg. You are applying 20 Newton force this direction. And your
Yes,
mu k given is how much? 0.4 and your mu s is 0.6. First, you find out what is F limiting. F limiting is how much? 20 into 0.6, that is equal to 12 Newton. Now you know that F limiting is less than the F applied. So this will tell, yes, the body will move. That's all. Okay, body will move. Now the body is moving. When the body is moving, there is no static friction acting anymore. This is gone. Now only Fk will act. So what is Fk? Mu k into n. Mu k is how much? 0.4. What is n? N is 20 Newton. So how much? 8 Newton. Now Fk this side is 8 Newton. Force this side is 20 Newton. So what will be your total net force? Net force will be 20 minus 8, that is 12 Newton. So what is your A? Your net F net divided by mass. F net is how much? 12 Newton. Mass is 2 2 kg. So how much? 6 meter per second square. Clear? That means your static friction will only tell whether it will move or not. After once it moves, static friction is no more applicable. That's why I did not include here the static friction, because static friction will tell if the body is moving or not, body will move or not. Once the body moves, this part is irrelevant. It is not applicable. You only talk about FK. Either your FK will act or your FS will act. Understood? Both cannot act. Clear?
Yes, sir. Understood, sir.
Both cannot coexist together. Either Fs or Fk. Fs will decide, F limiting will decide whether the body will move or not. If the body is moving, then F limiting is gone. That's all. Clear? Is it interesting?
Yes, sir.
Is it interesting?
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
All of you?
Yes, sir.
Very good. So we will end the class with one more concept that is called graph of friction. What is graph of friction? What is graph of friction?
It shows like how the friction acts, sir.
Yes. Here static friction Fs is equal to applied force. So this part, which part? This part till here, this part in bold is actually rest part. Rest part means what? That means the applied force is equal to the friction force. The body is not moving. So the Fs is equal to applied force. Correct? F applied. All of you clear? This part.
Yes,
Till
sir.
this part, the body is not moving. Body is at rest. That means what? Your F limit, the static friction is equal to the F applied. So net force is 0. That means the body is not moving. Clear? But
Yes,
exactly this point, there is a limiting force that is called limiting friction. That is in dots. This is called F limiting. Understood? Just about to move. This part is just about to move. Clear? Just about
Yes, sir.
to. And this is what? This part is what?
FK.
FK, kinetic friction, which is a constant. Because see why this is now, you tell me, what do you mean by this? This means what? It is varying. Your static friction is varying. It is increasing, and here it is maximum. But whenever you draw a graph like this, it means what? It is a constant. That is why from this figure, it is clear that your static friction is a variable friction, but your Fk is a constant.
Constant.
Clear? And this is motion. This is motion. Clear? And note down applied
Yes, sir.
force. This is friction. Are we good? All of you?
Yes, sir.
Yes,
Yes, sir.
sir.
आज थोड़ा ज्यादा हो गया? Too much today? Too much concepts?
No, sir.
No. Easy, no?
Yes,
If
sir.
you understand, it is easy, beta. If you don't understand, it will be nightmare. I am telling you. If you don't understand, if you simply just mug, physics will be nightmare. It will haunt you. Night, it will come and bite you everywhere. From everywhere, it will bite you, and you keep on scratching. But if you understand, no, physics will be what like mouse. Chocolate mouse, have you eaten? Chocolate mouse, like that it will be. It will be amazing.
Yes, sir.
So I wish you Merry Christmas. Let all be happy, all be good. All of you, or not you, all your family. Pritam, please convey my regards to your father. Merry Christmas from my side. Laksh to you, Siddhi, I already met you.
Yes, sir.
Group to you too, wherever you are, keep studying. Doesn't matter wherever you are, be anywhere in the world, doesn't matter. Technology binds us. Yes or no? We are virtually connected. Yes?
Yes, sir.
Our hearts to be connected. Physically, we need not be together, but our hearts to be connected. That's how it becomes very important. Always do not forget your teachers. It is for me also it is applicable. I never forget my teacher. Always respect your teacher, love your teachers, follow whatever they say, because they will always want. I'm telling you, the maximum reward for a teacher is always remember that it is us. We see that you are prospering. I was teaching Laksh will know. Laksh, you know, no? That uncle, daughter, Srinivas uncle, or what
Yes,
is his name?
sir.
His daughter. I taught him for 1-2 months. He scored 90%, 90 something he got. Physics, he got some 95. So that is my achievement. My achievement is nothing, yaar.
Somashekar uncle, sir.
Thomas Shekhar uncle. I'm sorry, forgot his name. Is he here or he is left? Has he left Mumbai?
No, sir, he's here.
He's here. Oh, but uncle and auntie on left, right? Auntie on the left. They are not.
Yeah, she left.
Okay. So it is the achievement is only the students when they are rising. You all cracking NET exam or JE exam. I'll be very happy. Siddhi wants to become doctor. We don't know. So Pritam might be an automobile engineer. Pritam, what do you want to be? Pritam, what do you want to be in your, what is your motto, this thing?